videos on this. If you want to like check it out on Khan Academy, if you forgot what something is, you can. I'm not going to play those during class. I'm going to teach you guys. I know some of the other teachers are going to play them and they're going to take notes from there and then talk about it, but I'd prefer to teach you guys. I like teaching. So anyways, there are video links there if you do want to go to them. Obviously, I also record my lesson and that will be on the classroom as well if you need to go back and look at that. But today we're going to be talking about points, lines, and planes, and apply and solve problems relating to the properties of points, lines, and planes. So the biggest thing about today is learning about how to label the points, lines, and planes correctly. Because if you don't label them correctly, I will not know what you're talking about, especially when we get to constructions on Friday. Remember, get those compasses, right? Get those compasses by Friday. Can I see that binder that you got? So folders work. But I'm sure this binder wasn't that expensive, right?
I just had it at my house.
You just had it at your home. Tucker also got just this binder that has like the middle one. Completely fine, okay? So anything like that to put it in. Have that by Friday. Again, a compass looks like this. Has a Sharpie pointing part that we'll be using and a pencil. So make sure you have those by Friday because you'll be getting that construction portfolio on Friday. And you'll need to know what these are because you're going to have to label these things when you're doing your constructions the correct way. All right? Okay, let's get started and just review really quickly. And remember what things are asking us. So if it says find the coordinates of the midpoint, that means you're finding the middle, which means you need an average. Remember, middle is like the same thing as average. So when you see midpoint, kind of think average. I'm going to find that average there, which means I'm going to add them together and divide by 2. So understanding what your directions are asking you are super important in any class. So I think that it's important you're understanding what they're saying. Underlining directions is a really good habit to get into so you really know what you're talking about, underlining the main points. And maybe even if there's steps along in the directions, maybe labeling them 1, 2, and 3 so you know which things you have to do and if you've done them all are really good habits to get into. Okay. Corey, how can I find the midpoint of the x's then for this one? We're using this point here. G is 4, 2, and H is 8, negative 6. So what would we do for the x's? What are your x's first?
4 and 8.
4 and 8. So what are we going to do with 4 and 8 to find the middle?
I would subtract.
Be careful. When you take the average, do you subtract them? What do you do when you take the average?
Add them.
You add them all up, right? And then you divide. So how many would we divide by if we add those two things up? Corey, how many?
12.
Well, that is 12, but what are you going to divide by?
2.
2, because you have 2 pieces. So you're right, that's 12 over 2, which is 6. So we have the middle of x's is at 6. Okay, Dylan, for the y's, what would you do?
You would add negative 6 and 2.
So you'd add negative 6 plus 2, and you'd do what with that?
Divided by 2.
There's 2 pieces. So what's negative 6 plus 2?
Negative 4.
So negative 4 divided by 2, which is? So Dylan, Keith, what would I have in the end then?
You would have 6 times negative 2.
Very good. Okay, so understanding what your directions are asking you. A distance is a length. So if you're trying to find the distance, you're going to be using that distance formula, not the middle, so don't use midpoint formula. This is one of the biggest mistakes I've seen in the past when I've taught geometry is mixing up the formulas. So remember, the distance formula is this. And yes, you need to know these formulas by the time you have a quiz or a test, which will probably be next week sometime. Probably on the block day next week would be my guess. Okay, so be ready. I'll let you know for sure on Friday, but be ready that you'll probably have your first quiz next week, probably around the block day. So if I'm finding the distance, I need to know my change in x and my change in y. Landon, what's my change in x? How much is it change from 4 to 8?
4.
Lexi, what's my change in y? What is the difference of 2 and negative 8? Or negative 6, sorry. It is 8. Very good. -6 is over here before 0, and 2 is on the other side. So you have to go 6 to get to 0, and then another 2 to get to 8. So very good. That gets confusing sometimes for you guys. So that's 4 and 8, and then we just plug it in. So we have distance equals the square root of 4 squared plus 8 squared so that's 16 plus 64. So that's 80 there. Sophia, right? What do we need to do here, though? We still need to simplify it. So what goes into 80?
8 and 10.
Okay, what goes into 8?
4 and 2.
So that's 2 and 2. And what goes into 10?
5 and 2.
Very good. So I have 2 times 2 times 2 times 2 times 5. Tucker, how would I write up that final answer then? Perfect. 2 times 2 is 4. The 5 doesn't have a partner, so it's still trapped underneath the radical. All right, looking at that, what questions do you guys have for me so far, just reviewing what we've done so far? All right, and we're going to get into stuff. Alrighty, so today we're going to be talking about points, lines, and planes. Like I said, there's a link to a video if you want to look at that too. Obviously, I will also link my own video to my Google Classroom if you need to go back and look at stuff. But let's first start with a point. Technically, if you're thinking about a point, it's like a location on a map. We are currently in St. Peters, Missouri, right? That is a point on the map, right? If we wanted to get to somewhere else like St. Louis, that would be another point on the map. Points do not have any dimensions. Technically, you can't even see a point. We just represent it with a point, okay? So points are typically really tiny things that you can't see. They don't have any dimension. They exist, but they don't exist at the same time. But we represent it with a point so we visibly can see them. So points do not have a dimension, so it's really important you realize that. And they represent a location. For us, it will be like a location on a line, or a location on an angle, or a location on a ray, or a location on a segment, or a location on a plane. That kind of stuff will be what lines actually, or a point actually represents. Without points, you cannot create a line. Points make up a line. Infinity amount of points make up a line. But it is important you realize that points have no dimensions. So if we're thinking about a point, for example here, they are always labeled with a capital letter. So that's an example. So they are always labeled as with a capital letter. So that's an example. They're always labeled with a capital letter, and when you go to tell somebody what the point is, the description of it, you always write it as point in whatever that is. So this is point A. I'm trying to think how to categorize this one, besides label, because I used it over there. I'm going to put written as. So if I ask you to tell me a point along a line, you would have to tell me, write the word point, and then the capital letter that represents that point. So again, points do not have any dimension to them. They're just like a location on something. For us, a line or a segment or a ray or an angle or a plane, whatever we are talking about at that point, okay? So that is what a point is. So a line segment. A line segment is a two-dimensional I'm going to just put object there. So it's a two-dimensional object made up of points. So first of all, a line segment is made up of points. It's two-dimensional, meaning that you can actually see it. So two-dimensional means that it's just on one space here. So like if you're looking at the tiles and you can see the cracks in the tiles, you know, where they meet, those are lines, right? That is a two-dimensional object. There is a line going this way, there's a line going that way. Technically, where these two, the wall and the floor meet, is another line. Okay? So those are lines. If you look at the ceiling, the tiles on the ceiling have lines that are connecting them to put the rectangles in place. Those are lines. They are line segments because they are finite. So, first of all, if you look at the ceiling, you can see that that tile starts at that wall and ends at that wall. Do you see that? That's what makes that a line segment versus a line. So a line segment is a finite distance, meaning it doesn't go on forever. It has a start and stop point. If you look at this, we know that this line starts here and ends at that wall there, and it's done. It's a line segment. So there's a difference between a line and a line segment. Line segments start and stop. So if we're looking at the line segment example they have here for us, it's already written in there. They have the point AB. I'm just going to redraw it to create it. Notice it doesn't have arrows at the end. It has 2 points telling it to start and stop. You could measure this. It is measurable. So when it says it has a finite distance, that means it is measurable. So that if that makes more sense to you, you can write that next to it. So it is measurable. Label it, you use 2 capital letters. Which represent points. So you're using 2 points along the line segment to label it. So use 2 capital letters, which are the points, 2 points along the line segment. So it's going to be written as, there's 2 different ways you could write this. So in this case, you always use the 2 capital letters. If it's a line segment, there's no arrows on the end. So if it's a line segment, you just put a line on the top of it. That's a segment because it has no arrows, meaning it starts and stops. Or you can write line segment AB. But you must use 2 points that are capital letters to do this. Right, looking at the first 2 definitions, there's a lot of definitions today, so a lot of me talking at you before we get to examples. Do you guys have any questions so far? Because we're going to be now looking at line segments versus rays and versus rays and versus lines, okay? So those are a little bit different. All right, so a line segment would be like if we had 2 points, St. Peter's and O'Fallon, the line segment to get there, if it was a straight line distance, that would be a line segment. It starts and stops. You start in St. Peter's, you end in St. Louis. That is a line segment, okay? Now, if we're looking at a ray goes on forever in one direction. It doesn't matter which direction it is, but it goes on forever in one direction. It is also 2-dimensional. So since it goes on forever in one direction, you cannot measure it. Just so you realize that. Cannot be measured. Because it goes on forever, it has an infinite length. So think of a ray as like a ray of light or something coming from the sun. Although we don't necessarily see it, it has a starting point, the sun, and let's just say it goes on forever, right? The sun technically doesn't have a stopping point of where that ray is going to end, right? It's going to go on forever, but it started at the sun. Or think about scientific, science fiction type stuff, like ray guns and stuff like that, right? It has a starting point of the gun, and the ray would technically go on forever because it's like a laser. So that's the kind of thing that a ray is. It has a starting point, and it goes on forever from there. And it is 2-dimensional. So for example, it has the examples here. Is that ray there? It has that point. It has 2 points labeling it. But notice the difference between a segment is that it has an arrow on one end. It does not matter really which way the arrow goes. It could have been this way too. Rays can go in either direction. It doesn't matter. Also, it really doesn't matter when you label line segments. If you would have, like on the previous slide, if we would have done AB or BA, it's the same thing. I think some people like to keep it alphabetical, but they're the same thing. They mean the same thing. So you label it by 2 points again, which means that they're going to be 2 capital letters, because points are always capital letters. And when you go to write it up, as you guys are doing your constructions and such, it's going to be written as ray AB or BA, it doesn't matter, or you can write it up as this, like this. AB with a ray on it, or you could do BA with a ray on it. What matters is that it doesn't matter which order you put the letters in. What matters is that your arrow is always pointing to the right, and that you only have one arrow, not two, to signify that it's a ray, meaning it goes on in one direction forever. It does not matter which direction it's pointing on your paper, just always make the label go to the right. Okay, questions on what a ray is? So the big difference between a line segment and an actual line is that a line segment can be measured, but a line cannot. It's still two-dimensional, but a line goes on forever in both directions. There's no like starting and stopping point at all. Where a ray does have a starting point, it just never stops. So it is two-dimensional. And a ray or a line cannot be measured because it goes on forever in both directions. So a line is never ending. So there's multiple ways of labeling a line. Typically when it's, here, I'll talk about that in a second. So let's do some examples here. So the examples they have for you up there have points A, B, or just a line with an M, typically italicized if it is a letter. It's a lowercase. So it can be labeled with two uppercase letters, which are 2 points, or this one has another option, or sometimes a line will just have a lowercase letter along it that's italicized, so it can be labeled as with a single italicized lower letter. So it can be labeled with 2 uppercase letters, which are points, or a single lowercase italicized letter. This cannot be used for rays. This cannot be used for line segments. Only lines allow for you to have this or option. So when you go to write this up, if I tell you to give me a point or a line in this case, you could write it in multiple ways. If it gives you the capital letters, you can use a line above the 2 capital letters that have arrows on both sides. That just signifies a line versus the ray that has the arrow on one side because it's only going in one direction, or the segment that has no arrows because it is measurable. Or you can write line AB. Or if it has a lowercase letter, you can write it as line M in the lowercase letter. So those are some ways you can do it. Again, order does not really matter to me about what you do it. You could do BA. That's completely fine. So looking at those, what questions do we have so far about the 4 things that you have learned about so far? We're getting through some definitions, and then we'll get into examples. Geometry has a lot of definitions in it. Something that you guys don't know very well. There's a lot of postulates and theorems we'll be learning about next week and stuff. We'll start that stuff, so make sure you guys are really, some of you guys might need to make flashcards, okay? Some of you guys will be really good with this stuff, but if you're not good at remembering what words mean, you really might want to make flashcards that have the examples drawn on it and what they mean and everything, so that when you see it on a test and it says to label the point, you know exactly what to do. Or if it says, is this a line segment, a line, or a ray, you know what that means. Because of the amount of definitions in geometry, you might want to find a way to study. All right, by making flashcards. I know there's sites online that also make those things. All right, so let's do this first example together. Name the following using the figures below. Okay, so the figure below is what we're using. Okay, Mariah, give me a point that's on there. And how would you write that? No, it's a point, so you'd say, yeah, point L, and you just use that single letter. Because it has no dimension to it, it's one letter. If it's 2 dimensions, it needs those 2 letters. If it's 3 dimensions, you need the 3 letters. So kind of think about the dimensions and how many letters you'll need typically. Give me another point, please. Cameron, go ahead. Point K. And again, make sure you're using it as a capital letter. Even if you like only lowercase letters, you have to write them as capitals. Alana, give me another one. How would you write it? Good. Again, capital letters. So just to know, points use a single capital letter. So if you get confused, you can reference that. Okay, 2 segments, and this is referring to 2 line segments. So it doesn't say this, but 2 line segments. So to label a line segment, you use 2 points. So give me a line segment. Give me a line segment. Brandon, go ahead. L what?
LM.
LM. You can measure LM, right? That is measurable, but you have to put the line above it. So you can say LM or line segment LM. I think that way seems a little bit tedious to be writing that much when you can just put LM with a line over it that has no arrows on it. So do what you would like to do. Cameron? KM? Yep. Again, make sure those are capital letters, so 2 points, which need to be capital letters. So you can write that as KM. Make sure there's no arrows on the end, or line segment KM. Brandon, give me a ray. It's not much different from the line segment. It's just going to change what you put like the hat on top of it. So give me some points. 2 points. And what do you need to put above the K and M that's different from a line segment? Just an arrow, and it's always pointing to the right, so that's KM. So you can write it like that, or ray KM. So it should be 2 points, or which are capital letters. Paige, give me another one. LM. And its hat is going to have an arrow on it. I'm just going to call it a hat. That's not really the right name for it, but That's what it looks like. Questions on the labeling of 1, 2, 3? What questions do you have for me so far? Okay, Melinda, give me a line.
KL,
And what needs to be on top of it?
a line.
An actual line, right, with 2 arrows on it?
Yeah.
Or you can say line KL. What if, I know this isn't on here, what if I had a lowercase, let's just call this lowercase l here. How could I label that then? What if that was there? What could I write? Right? Line L. So if you want to put that little L there, that cursive L at the end there, just to show you guys a different way, because sometimes it's nice to see different ways on your notes so that when you see it in your homework, you can do that. So remember, when you label a line, you need 2 points or a single lowercase letter. So 2 points, which are capital, or 1 lowercase letter. All right. Questions so far before we get into some more definitions? Questions so far? All right. Then let's talk about collinear and non-collinear. Okay. What word do you see inside of collinear and non-collinear? Linear, which means the same thing as a... What do you think of when you say linear? Line. So you should be thinking line when you see this because you see linear in there. Now, non means not typically, right? So that's where these definitions are going to come from. So the definition of a collinear is points on the same line. So along the same line, they're collinear. The definition of non-collinear points not on the same line, which makes sense because non means not, so not on the line or on the line. So just trying to use those context clues if it asks you to label, it could be something that's collinear versus non-collinear. Understanding what those little pieces mean can help you guys get there, all right? So we're going to use the follow figure again. So name 3 collinear points for me. So Madison, name 3 collinear points for me, meaning they're on the same line.
K, L, and M.
So we're going to say point K, point L, and point M. Just label them right. Again, you're learning it, so it's all good. They all sit on the same line. When you are talking about non-collinear, obviously 2 points will always make a line. I don't know if you realize that, but 2 points will always make a line. So that's really important you guys realize that. So 2 points will always make a line. So you just need a third point that isn't on the line. Because 2 points will always make a line. So if I ask you to give me 3 non-collinear points, meaning one of them needs to not be on the line, one of the 3 points, so I can write that as that. Give me 3 points that would signify something that is non-collinear. Bryce, when you're ready.
N.
You gotta give me 3 though.
Point N.
Good?
Point K.
Yep, and point.
Point M.
Yeah. So these 2 are obviously a line because 2 points make a line. Even if you would have just given me K and N, that could create a line, right? But point K and M are linear, but the N makes it non-collinear because it's not along the same line. You cannot keep your pencil going straight to get to N if you were to try to connect them. You would have to make a jut, right? It wouldn't be the same line segment anymore. So, point N, point K, and point M. So, one of the points is not on the line, and that is point N. All right, what questions do you guys have for me so far? Okay, this collinear idea and non-collinear point is going to be really important when we're talking about planes. So if you don't understand it, please ask a question now. All right, so let's talk about planes in space. So a plane is a flat surface made up of 3 or more points and extends forever. So technically your desks are a plane. Now, do they extend forever? No, but it is a flat surface, right? Do you guys see that? The floor is a plane. The ceiling is a plane. The wall is a plane. It has 3 dimensions to it, so it's 3-dimensional. It has space. So coplanar, so just so you guys realize this, so when you go to label a plane, just so you guys realize, let me make this one here. I'm going to make that a capital L. I'm going to give you some points on here. Go ahead and write down what I'm doing here. Bless you. So it's labeled with 3 non-collinear points. They have to be non-collinear or else it's just going to be a line, okay? And that's not necessarily a plane. So it has to be 3 non-collinear, meaning not along the same line, points, which means that they're capital letters, or an italicized capital letter. I'm going to do this up here. I know this is really messy, but it's going to be written as, so some examples are, gosh, I can't write right now, written as plane, and in this case I'm going to use A, B, C because they're not collinear, or you can just say plane, and in this case I have that capital italicized L on there, L. So it doesn't matter which one you do, but just make sure, notice A and B are collinear. 2 points form a line. But I couldn't keep my pen going through them to get to C, right? There's no way to do that. I'd have to turn my pen. So if C happened to be along the same line, you couldn't use A, B, and C. So for example, if I had another point here that was D, my pen can go through all of those points. You cannot use A, B, and D to label the plane because they are collinear. They have to be non-collinear, meaning not on the same line. Okay? Hannah, what's up? Confuse you, obviously, because you just did this. It's just a lot of words right now. Is that more what it is? Okay, again, flashcards might become your friend this year. You have probably typically not needed that in math before, but because of all the definitions that come with geometry, you might need that this year. All right? All right, so coplanar, much like collinear, you see the word plane there. That means it's points on that lie on the same plane. And then if you see non-coplanar, meaning not on the same plane. So let's talk about this conceptually. If I have a box of tissues, actually, I'll use this card box here. If I have this large card box here, it has multiple planes on it. How many planes are on this box? Can somebody tell me? How many planes are there? Remember, a plane is a flat surface, so how many planes are on this box?
6.
6, right? You have the top and the bottom, that's 2. The 2 sides, which is 4. And the front and back, which is 6. So you guys all understand what a plane is? You guys got that? Okay. So it says that they have to be points that lie on the same plane. So like if I'm looking at these flowers here, these flowers are my points, right? That lies on the same plane. Got it? But if we look at the bottom of the box, this flower down here and these 3 flowers have a plane, or these 3 flowers and that one do not have the same plane. You guys see that? They're on different planes. This one's on this one, and the other 2 are up here. So that would be non-coplanar. Does that make sense to you guys, seeing it visually? So, for example, 2, this is a line here. You guys see this line here that where it folds over to write the other one? A line can create 2 planes, right? Because you can put a plane like through it, like our floor and our wall. We have a line here. Do you see the line that connects the floor and the wall? That is also possible. So that a line could be on 2 planes, technically, or more, actually. All right, questions so far on that? Questions? All right, so space is a boundless 3-dimensional set of all points. Space can contain lines and planes. Any questions so far before we get into a million examples? All right, so I'm going to call on you guys. Answer the question as best as possible. I will help you out as much as I can as well. So, okay, this is hard because this graphic is 2-dimensional, but planes are really 3D, right? So that makes it a little bit hard because it's not, we can't physically make something 3D for you. We don't print it that way. All right? Obviously, there are 3D printers now, but still. So label each of the following. So give me a line containing point A, and we're going to name it in 3 different ways. So Melinda, give me a line containing point A, and we'll name it 3 different ways. And what do you have to put over AB if you're going to say it that way? With the line over it, so you could do it this way. AB contains it. Give me a different way to label the line. Cameron? That's not how you can do it. It has to be done in a specific way. There's 3 different kind of ways to do it here. Hannah, what's another one?
A, B, C, D.
We only use 2 points to label a line. So a line is 2 capital letters or 1 lowercase italicized. So does somebody else have a different one after I said that? Anna, do you want to try again or no? Okay. It's okay. Guys, you are learning. It's okay. Cameron. Line M? But it's not an M on this case. What is it here? What's the italicized letter? Those are all capital letters. See, this is confusing. You guys are learning something. It's new. What is my lowercase italicized letter? It does look like an E. That's technically an L in cursive. I understand why you said E. So, yes, you could write line L. Or E if you want to call it an E. Completely understand why you said that. But you can't say just line A because that's a capital letter. You can't just say line B. That's a capital letter. You can't just say line C. That's a capital letter. You can't just say line D. That's a capital letter. Going off what Hannah said. Sorry, Hannah. You can't do A, B, C, D. That's 4 points, not just 2. All right? It is a line, but I only need 2 points for it. So give me another 2 points that I could use to name this line. Jordan, what's another 2 points I could use? You could say line AC. So those are 3 different ways you could label that line. Notice I never used more than 2 letters. And if I used something that wasn't capitalized, then I could use a single letter. So what questions do you guys have for me? All right. This is Let's try this plane situation. Remember, in a plane, that has to be plane containing point C. They cannot be collinear points. Just so you know. Also, a plane is named with 3 capital letters or 1 uppercase italicized letter. So I'm rewriting everything we wrote down on the other slides as a reminder of what you're going to do, because I'm hoping that will help you guys out a little bit. I know it's a lot of writing, but I'm trying to help you out here. So Corey, can you name this plane for me? So you either need to give me 3 capital letters that are not on the same line or 1 uppercase italicized letter. Okay, that's 1 letter. That's not italicized. That's a capital letter, though. Give me 2 more. L is not a capital letter. That's just along the line. So it's 3 points. So give me 3 points. So E. What else? N is not a point. It's just an italicized letter. It has to be another capital letter. So E, you've chosen everything else, but everything else should work now. B and A. Can name the plane. So plane A, B, E. Okay. Somebody else want to take a stab at this? Cole? Plane N. He can use that single letter because it's italicized and it's capital. I'm making it funky looking for that reason. Okay, one more way of naming this plane. It's going to be very similar to the first way. Just give me different letters. Melinda? Plane EBC. I just like them alphabetical. It doesn't matter. I would take both of them. All right. If you would have told me plane ABC, you would have been wrong. That's along the same line. Okay? If you would have told me plane BCD, that is wrong. It is along the same line. If you would have used this letter L in any way, shape, or form, you would have been wrong. That is not a point. It must be a point. Do we understand that? Okay. So let's try the next one. Name 3 questions. Go ahead, Tucker.
It said the plane had to contain point C,
But this is one plane. So this plane contains point C every single time. This is point C. So like what that's saying is, say there was 2 planes that were going through this, and this was one plane and this is another. C's right here with all the other labels. So we just had to name it any way that was on this plane. Does that make sense?
Yeah.
Okay. Very good question. Name 3 non-collinear points, meaning they're not along the same line. Not on the same line. Hannah.
Plane CDE.
Points. Those letters are beautiful, but I need just points. So say point in front of all of those letters.
Point C, point D.
Yes. So it's point C, point D, and point E. So we want to know point. So points are a single capital letter. Okay. Seriously, ask questions, please. Please and thank you. You are supposed to ask questions. You are the student. You are learning. You do not know everything. It is okay to not know something. I don't know why you would be sitting in this room if you knew this already. Really, why would you be, okay? So it's okay to ask questions. All right. When you're ready, go on and flip to the next page. We're just going to take the whole entire block period to go over this stuff today. Okay. Let's do this. Yes.
So when you're labeling, like when you put the lowercase letter, is it always going to be on?
No. I just like the letter L because it means line. Also, it's really easy to write cursive and italicized, so that's why I like the letter L. But like you'll see other letters and they label lines. Like on the first slide that had the line, it had an M there. That's fine. It can be any letter of the alphabet. All right. All right. So how many planes appear in this beautiful figure here? How many planes do you guys see? What?
4.
Who said 4? Tucker, tell me what you're seeing. Come on up here and just point to it for me. Because otherwise it's going to be really hard to explain, I think. So Tucker, what do you see?
Here, and down here.
Yeah, so it looks like there's 5. Some of you might have said 5 because don't you see like the 3 faces of this pyramid here? But the third face is sitting on this plane here. Do you guys see that? So it's still just one less plane, so that's 4. So you have the back of the pyramid, the 2 back parts of the pyramid. Oh wait, it's not 4, sorry. It's 3, I counted wrong. So it's 3. Do you see how the third part here is on the bottom? Oh wait, you're right, it's 4. I'm going crazy, I'm pretty sure. Sorry, as I'm confusing you and myself. You are right, Tucker. It is 4. So the front of the face is the first face. The 2 back of the faces are the 2 and 3. Do you guys see that? And the bottom that is sitting on the plane is the 4th. I don't have anything that looks like a pyramid, I don't think, or else I would totally be doing this right now with a pyramid on top of this box. Trying to see if there's anything that I can use for that. Do not have anything. I can use pieces of paper though. Okay, so for example, if you're looking at this box up here, it's sitting on this face here, and it has a pyramid. I would need triangles for this, but it's a pyramid that has these 3 faces and act like it's a triangle that's sitting together. Okay, do you see why the 4th face down there is on the bottom? Pretend it's coming to a point at the top, please. Okay, so you see the 3 pieces of paper, right? And the bottom one is sitting on the box, which is why it's only 4 and not 5. All right? Just pretend that there was a point at the top, everyone. All right, so there are 4. Name 3 points that are collinear, meaning on the same line. Alana. D, G, and B would be perfect. They're on the same line, but you need to say point D, point G, and point B. Are points G, A, B, and E coplanar? Are points G, A, B, and E coplanar? Sophia, I saw you shake your head no. Why not? So if we're using like the labels I told you for the planes, say like this bottom one's 3, the front face is 4, 1 and 2. So if you're just looking at it that way, can you explain it?
Like most of them plane 3, but then G's on plane 2.
Yeah, whatever plane you want to put it on. It's on 2 different planes, right? So like if you look at it this way, A, B, and G are all on this front face, right? But E is not along there with it, is it? Or you could say E, A, and B are all on this bottom one, but is G on that plane too? No, so that's the problem, is one of those points is always off of the plane. It's not on the same flat face. So no, because we'll just look at one of the planes. The bottom plane there, points A, B, and E are on the lower plane. But G does not sit on that point. But point G does not sit on that plane. Don't mind me, I'm just gonna stab this sheet of paper too, so you're aware. Alright, so the next question asks you, this pencil is a line, this piece of paper is a plane, okay? The next question asks you, at what point does EF, so this is the line EF here, that's what this pencil is, okay? And plane P, this is this plane, intersect. So at what point does it stab through the plane? At what point is it stabbing through the plane? That's basically what it's asking. So, Dylan Keith, at what point does it stab through the plane? So this is the line segment EF, and this is the plane. At what point is it the stabbing point? Point E. You know, because stabbing is a geometry term now. Are you confused, Hannah?
Yeah.
Okay. If I could just write on this, I will. But so, like, if you're looking at this, I'm going to come to you. The eraser will be F, and E is right here. Do you see that? And the dotted line symbolizes that it's going underneath. So dotted means it's behind. So like A's down here. So this is like F, A, and then E's there. Do you see that? So dotted lines symbolize going through. Just to let you guys know if you didn't realize that. Just gonna leave that piece of paper there for him. All right. What other questions you guys have? Then let's go on to the next one. Okay. Whew. We have a lot to do still. Let's see here. Ben, give me a plane. Doesn't give you many letters, so you have to use what's given to you. So a plane can be used, remember, a single italicized capital letter. Do we have a single italicized capital letter? We do. These technically should be capital italicized. What are they? So you could say plane Q. So one of your planes is plane Q. Okay, give me a line. Dylan, give me a line.
Line DR.
Yeah, line DR. And I'm going to just put the little line head on top of it. So remember, when it's a line, you have to have arrows in both directions. Corey, what is a line segment? There's really only one. DR, but what's the hat going to look like this time? Just a straight one without the arrows, right? Give me a ray. Brandon, vote.
ER.
But what is it going to be on the hat this time?
Arrows pointing to the right.
An arrow that's pointing to the right. Name the intersection of the planes. Planes always intersect at a line. Planes always intersect at a line. So, at what line is planes P and Q intersecting? Only I could shove this through the middle. At what line would those planes intersect? That's all it's saying. Do you see how it forms a line when it intersects? Do you guys see how this piece of paper is like a line here? So when they intersect, it's going to form a line. So what is my line going to be, Cameron? DR. They intersect at this line here. Do you see how the plane is going through DR this way and that way? So they intersect at that point. Or line, I should say. So, side note, if you have two lines that intersect, they're going to intersect at A. So if two planes intersect at a line, what are two lines going to intersect at? What, Brandon? A point. There's a single point that they're going to intersect at, okay? So one below it, essentially. One dimension below it. Draw AB in plane Q so that it intersects ray DR at C. So I guess we're going to need a C on here somewhere. So we're going to put a C along this line because it's saying it has to intersect it at C. So that means C needs to be along that line, or that ray in this case that it's saying. And then we have to draw AB as a segment in plane Q, which is the top plane. So they need to be collinear. And you have a line segment. Notice, is there arrows on them? Are there any arrows? No, it's a line segment. Line segments don't have arrows. They are intersecting DR at C. A, B, and C are collinear because they're along the same line segment. Okay, now name 3 collinear points now that we have that. Name 3 collinear points now that we have that. Mariah. D, C, and R. So point D, point C, and point R. Capital letters, the word point in front of it. Name 3 non-collinear points. Landon, give me 3 non-collinear points. Points that do not lie on the same. So this is along the same line. So give me 3 points that do not belong on the same plane, which I don't know how you would do when we don't have points that are off there. Let's create another point.
Q, P, and A, maybe?
If P was a point, yes, that would work. I don't know if P is technically a point because it doesn't have a point there. Yes, though, if it was. So let's just put another point up here and make it M, okay? So so Q and P are not points. Those are labeling the plane. So if we put an M up here, what would your non-collinear points be then, Landon?
A, M, and Q.
Q isn't a point. It doesn't have a point next to it. A, M, and
D.
D. So A and D are along this plane, but M is not. But they're along that plane too. So, no, A is not. It's back here, so that works fine. So A, M, and D. So point A, point M, and point D. So what this is basically saying, just so you guys realize if you're looking at this box again, if this was plane Q on top and this was plane P, okay, this is plane P and this is plane Q, we have a point here, and then points A and M are along, or points A and D are along this one, and point M is down here. Yes?
Instead of writing point, can you just do like the point?
Nope, you have to write the word. I know. Your labeling it has to be done correctly. Sorry. No, it's a lot of work. Draw and label a figure for each of the following relationships. So first we're going to start with a line TU, which means that you should have a line segment that has T and U on it that lies in a plane Q. So I'm going to go through these. When I make planes, I kind of draw like a parallelogram to make it look like it's that way. I'm going to label it Q. And contains a point R. I'm going to say so this is saying that TU lies in plane Q and TU also contains a point R. So where does point R need to be then, if it contains it? Can R be off of the line or does it need to be on the line? If TU contains that, does it need to be on it or off of it? Yeah. It needs to be on it. So we have opposite rays, TR and TE. So if I put T here, TR is going in the left direction, and TE is going in the other direction. Isn't it an opposite ray that just happens to form a line? So many words in the next one. Goodness. Okay. So we have line RL that lies in plane M. So I'm going to draw the plane first. So this is plane M. And RL is inside of it. Line RL lies in plane M. Line RL also contains point E. So where does E need to be? So line RL lies in plane M. And if we go back here, RL also contains point E. So where does point E need to be? On the line. Also, this RL is not linear, not along the same line of point S. So where does point S have to be then? Not on line, but in the plane. So over here is fine. Okay? So that's what that's saying. Not sure what that was, but that one should be right here. You're okay. Somebody's on the ceiling, I think. Or the roof, I mean. Okay. Last slide here. Planes K and J intersect at line R. So two planes intersect at a line, which is really hard to draw. If you're drawing behind, when you draw behind, it goes, you use dotted lines. So that's behind it, so I'm drawing a dotted line there. Might have to erase some stuff, because some stuff is going to be underneath. So I'm just going to erase dotted lines next. Make this smaller. So underneath should be dotted, so I'm making it dotted over here, because that's behind it. This is really difficult to draw, I'm sorry guys. Planes K, J, and then that's line R. Except I didn't even make it go through the line. So 1 second. Erase what you had there. That was bad. Oh, it did go through the line. I don't know what I'm talking about. I just need to extend my line. So they're meeting at this line here. I'm going to extend my line a little bit for you guys so it's R. It's hard to see it, but it's happening. All right, I'm going to get you guys your homework because you only have 13 minutes left in the hour, so